we now discuss the solution of a problem from the section Coordinate Geometry. The problem is based on the symmetric form of a straight line. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the first shift. The problem is, let P and Q be two distinct points on a circle which has center at C with coordinates 2, 3 and which passes through the origin O. If OC is perpendicular to both the line segments CP and CQ, then the set consisting of point P, Q is equal to. The four options are given. So we are given a circle with the center at C 2, 3 passing through the origin O. P and Q are two distinct points on this circle, and OC is perpendicular to the line segments CP and CQ. Then we have to find the coordinates of the points P and Q in this set. The set consisting of the coordinates of P, the coordinates of Q. So the four options are given to us. Solution. Let's draw the diagram. We have the x-axis, y-axis and the origin O with coordinates 0, 0. Given a circle with the center at C with coordinates 2, 3 and passes through the origin O. This is the circle C with the center C with coordinates 2, 3 passing through the origin O. Given two distinct points P and Q on the circle. P and Q on the circle. OC is perpendicular to both the line segments CP and CQ. This is also given to us. OC, this is OC, is perpendicular to CP and OC is also perpendicular to CQ. Then this implies P, C, Q are collinear and PQ is the diameter of the circle. Right. Now OC is the radius is equal to the distance between 0, 0 to 2, 3, that is under the square root of 13. And OCP is also radius, CQ is also radius. And CP is equal to CQ is equal to the radius is equal to root 13. And this is the radius R, this is also radius R. The equation of this circle is a circle with center at 2, 3 and radius root 13. Therefore, the equation is x minus 2 whole square plus y minus 3 whole square is equal to root 13 whole square. Let's call this as the equation 1. We continue in the next slide. So that is the diagram, and we have the radius as shown in the diagram. Let theta be the angle that this diameter PQ makes with the positive direction of x-axis. So the positive direction, so extend PQ to meet x-axis, and this is the theta. And theta is the angle that this PQ making with the positive direction of x-axis. Positive direction of x-axis. Now OC is perpendicular to PQ. OC is perpendicular to PQ. So the slope of OC multiplied by the slope of PQ is equal to -1. They are perpendicular to each other. Because they are perpendicular to each other, the slope of OC multiplied by the slope of PQ is -1. And the slope of OC is y2 minus y1 by x2 minus x1, that is 3 minus 0 by 2 minus 0. So this is slope of OC multiplied by slope of PQ is tan theta, and that is equal to -1. That implies tan theta is minus 2 by 3. And where this theta will lie? Theta will lie in the fourth quadrant. Okay, that's we discuss afterwards. Now the points x comma y at a distance r is equal to root 13 from C x1 y1, that is equal to 2 comma 3, with slope tan theta is equal to -2 by 3 are given by, from the symmetric form, we have x is equal to x1 plus or minus r cos theta, and x1 is 2 plus or minus root 13 cos theta. Y coordinate is y1 plus or minus r sin theta, that is equal to 3 plus or minus under the square root of 13 sin theta. We continue in the next slide. So that's what we have done so far. Now tan theta is -2 by 3. As I told you that theta is in the fourth quadrant where cos is positive and sin is negative. So cos theta will be 3 by under the square root of 2 square plus 3 square, that is equal to 13, and sin theta is equal to 2 by -2 by root 13. Yes, it's very easy to compute. Okay, we got, and we will put these values here, and x comma y the points we will see. So x comma y belongs to 2 plus or minus root 13 into cos theta. Cos theta value is 3 by root 13. 3 plus or minus root 13 into sin theta is -2 by root 13. And this is x comma y points, means the point x comma y is a point at a distance r is equal to root 13 from C 2 comma 3 on this line. That means we are going to get the P and Q coordinates. So the points what we are going to get, we will verify them whether they belong to the circle, they lie on the circle or not. If they lie on the circle, they will be P and Q in some order. So that will be x comma y belongs to 2 plus or minus root 13 cancels, plus or minus 3 minus or plus 2. Root 13 cancels, and we get this. And now x comma y belongs to 2 plus 3 5, comma 3 minus 2 1. Next point, 2 plus 3 5, 3 plus 2 5 comma 5. And 2 minus 3 minus 1, 3 minus 2 1. Next point, 2 minus 3 minus 1, 3 plus 2 5. So these are the 4 points what we got. And in this 5 comma 5 minus 1 comma 1, they do not satisfy the equation of the circle, and hence they do not lie on that straight line. So note that these two do not lie on the circle because they do not satisfy the equation of the circle given in 1. Agreed. So the remaining 2 points, 5 comma 1 minus 1 comma 5, you can check, they lie on the equation. They lie on the circle because they satisfy this equation 1. So, x comma y is what? The coordinates of P or Q. Therefore, the coordinates of P comma Q in some order, that is will be equal to the set consisting of 5 comma 1 comma minus 1 comma 5. So, these are the coordinates of P and Q as a set is given. So, what are the options given to us? So, our answer appears against the option 1, and hence our final answer is option 1. So, that is the discussion of the solution of the problem from the section coordinate geometry, and the problem is based on the symmetric form of a straight line. I am sure that you have understood the solution of this problem and concentrate on two-dimensional geometry, in other words, the coordinate geometry. And I wish you all the best. Thank you.